Wow, the stuff you sent over about working in Antarctica this week, I gotta say, it really hooked me right from that first page.
Oh, yeah.
The author, draws this immediate contrast with the Arctic, right?
Yeah.
Like even describing that, 11-hour flight down in this old LC-130, just crammed full of gear. It just screams extreme,
Yeah,
right?
because and that initial account really, I think, sets the scene, right? The idea that, those iconic big red parkas that we all kind of think about, they're not just for show, right? They're literally survival gear
Yeah.
in case of a crash.
Yeah.
And that kind of hits home. And I think the line that stuck with me was, Antarctic fossil hunting would be more akin to a military operation compared to the Arctic. And that tells you everything you need to know about this environment we're going to explore.
Absolutely. And then even landing at McMurdo, it's almost like this, sensory overload. The author describes it so vividly, this intense cold, the bone-dry air, and then this like searing brightness just pouring out of the plane. And suddenly you're trying to, walk on what feels like pure ice, and everything you thought you knew about, getting around is useless.
Right.
It's not just about the science anymore. The ice itself is this massive, unavoidable character in the story.
Yeah, it's a really important point that the author makes early on, that Antarctica isn't just a cold place, right?
Yeah.
It's actually a high-altitude continent buried under, incredibly thick ice.
Yeah.
So it's colder, windier, and significantly drier than the Arctic, where the ocean kind of has a moderating influence.
Right.
So whether you're at the research station or out in the field, your work in Antarctica is going to be defined by how you relate to this ice.
Yeah.
And I think that's what we wanted to kind of delve into for you today.
Okay, let's unpack this relationship with ice a little bit.
Yeah.
Because for most of us, ice kind of, conjures up images of like skating rinks or maybe cooling down a drink in the summer.
Right.
But the author throws us right into this world where ice is the size of small towns,
Yeah.
even continents.
Yeah.
It's a completely different scale.
It's a completely different scale.
Yeah.
And that scale is kind of essential to grasp the Antarctic experience, right? So you've got McMurdo Station, this relatively substantial research hub,
Right.
which they call McTown for short,
Right.
which is located on an active volcano,
Right.
which is fascinating in itself.
Yeah.
But then you realize that the airstrip serving it is built on the Ross Ice Shelf,
Right.
an ice shelf that's the size of the Mediterranean Sea.
Wow.
So it's almost impossible to comprehend the sheer size and dynamism of that.
And it's not a static landscape, is it?
No.
The author mentions these dark basalt rocks all around McMurdo, remnants of that volcanic activity.
Right.
But the fact that the airstrip has had to be relocated several times over the years because the ice beneath it is thinning due to climate warming, that's a pretty stark image, isn't it?
Yeah, that's a stark illustration that things are changing there.
Yeah.
And it's important, I think, at this point to bring in the international context.
Right.
So since the Antarctic Treaty in 1959, there's been a significant global scientific presence there.
Right.
So there are around 70 research stations operated by nearly 30 countries.
Okay.
Although the total population remains relatively small, under 4,000 people.
Gotcha.
So McMurdo, being a U.S. program base, has its own distinct flavor.
Wow.
Everything from the logistics to everyday routines, which might be quite different from, say, a Chinese or a German research station.
I see. So McMurdo itself almost functions as this kind of temporary hub, right?
Yeah.
The author even compares it to Mos Eisley or Rick's Cafe.
Right.
Kind of like this way station.
Oh, way station, exactly.
People are constantly passing through, either heading out to these remote field camps or waiting to kind of get back home.
Yeah.
And the author really underscores how unpredictable everything can be. Research projects getting pushed back by weeks, sometimes even months.
Right.
Or sometimes just scrapped altogether because of, the relentless weather or logistical hurdles.
Exactly.
Yeah.
And even while you're at McMurdo, there's still this understanding that you are on the ice.
Yeah.
It permeates everything.
Yeah.
And the author describes these initial weeks of, intensive training and thorough gear checks before anyone is certified to venture out into the deep field.
Yeah.
It's a place where the ice truly dictates the possibilities.
Yeah. Which brings us to this really thought-provoking idea.
Yeah.
That one of the glaciologists, the author encounters this guy named Sridhar Anandakrishnan, mentions almost casually.
Right.
He says, ice is hot.
Oh, yeah.
Now, your immediate reaction is, of course, no, it absolutely isn't. But there's some really fundamental physics behind this seemingly contradictory statement, isn't there?
There is.
It's not about the temperature we feel.
Exactly. So Sridhar, who made this fascinating transition from electrical engineering to glaciology after a kind of transformative experience in Antarctica with the seismometer, he's not talking about temperature in the way we usually understand it, right? His ice is hot concept refers to the fact that because of the unique way water molecules are structured, ice is surprisingly close to its melting point compared to other solids like steel.
Right.
So, think about it. You have to heat steel to thousands of degrees to become liquid, whereas ice is just a relatively small energy change away from becoming water.
Right. So the immense pressure at the base of these glaciers plays a significant role in this proximity to melting, doesn't it?
Yeah, it does. The sheer weight of the ice above exerts tremendous pressure at the base of a glacier.
Yeah.
And this pressure actually lowers the melting point of ice.
Okay.
So the ice at the very bottom is often right on the verge of melting, which has profound implications for how glaciers move across the landscape.
And this seemingly simple idea that ice is hot in this kind of, specific physical sense, then kind of ignited this really compelling historical scientific debate about the actual mechanisms of glacial movement.
Yes, it did.
This have Bishop Louis Rendu in the 1840s observing glaciers filling valleys and spreading out, leading him to propose this honey analogy. The idea that glaciers flowed like a very viscous liquid.
So Rendu's observations about how glaciers kind of conform to the terrain really led him to this analogy of a slowly flowing, deformable substance. And then you have James Forbes, who really popularized this viscous or plastic theory. And further developed this idea of ice flowing under its own weight.
Okay, but then Lord Kelvin comes into the picture with a completely different perspective. Focusing on the physics of pressure and melting at the base of the glacier. His theory suggested that this meltwater acted as a lubricant, allowing the entire ice mass to slide over the bedrock. He also considered the possibility of melting and refreezing occurring within the ice itself.
So Kelvin's contribution was really pivotal because he introduced this crucial element of basal sliding due to pressure-induced melting. And he also recognized that the internal dynamics of the ice, with its own melting and refreezing processes, played a role in its movement.
And then you had John Tyndall, who strongly contested the viscous idea, emphasizing the role of cracking and sliding over meltwater. Very much aligning with Kelvin's thinking. But as the author hints, there was a bit of, a personal rivalry with Forbes adding fuel to the fire.
Chuckles. Tyndall was quite vocal in his disagreement with Forbes. But ultimately, I think, as the author points out, each of these early thinkers captured a piece of the puzzle. So our modern understanding is that glacial ice exhibits this remarkable range of behaviors. It can act like a solid, a liquid, and a plastic. It can slide at its base. It can bend and deform internally. And of course, it can melt and refreeze. So it's this complex interplay of these different states that governs the intricate movements of glaciers.
It's incredible to think that something as seemingly straightforward as, frozen water can display such a diverse range of properties.
It is.
And speaking of diversity, the author touches on this, rich vocabulary that the Inuit people have for ice and snow. Highlighting their deep understanding of its various forms and characteristics.
That's such a valuable point. And while the precise number of words might be debated, the Inuktitut language undoubtedly possesses the sophisticated vocabulary to describe these subtle nuances of ice, its shape, its strength, its suitability for different purposes. And the author brings this to life by describing, the diverse forms of ice that they encountered around McMurdo, ice that looks like syrup on mountains, ice that shatters like glass foamy ice. Quilt-like ice-folded ice blankets on the sea. It's almost magical how a simple chemical formula, H2O, can create such a spectrum of shapes and behaviors.
From individual ice crystals to these massive ice sheets spanning the size of North America.
It
really recalibrates our everyday perception of ice.
It does.
And locked within all that complexity are these invaluable clues about how our planet's landscapes have been shaped over millennia. And how our world continues to evolve.
Absolutely. And this kind of leads us to the author's own personal connection to these icy realms, this compelling search for ancient fish fossils. Now, it might seem counterintuitive to look for remnants of creatures that once thrived in tropical climates near the Earth's poles. But the theory of continental drift beautifully explains how rock formations that originated near the equator millions of years ago
Right.
can now be found in Antarctica.
Right. And this groundbreaking discovery of the fishapod in the Arctic really galvanized this search for similar transitional fossils in the Transantarctic Mountains, right?
It hit.
Where pioneers like Scott and Hillary and, Margaret Bradshaw had already unearthed early fish fossils. And it's great that the author specifically acknowledges Bradshaw's significant contributions.
It is,
as a female explorer in Antarctica.
Right. And the author's own expedition, in a sense, following in Bradshaw's footsteps, really brings these practical realities of conducting research in this extreme icy environment into sharp focus. So, the absolutely critical role of the mountaineer Forrest McCarthy in ensuring the team's safety and constantly assessing what is even feasible each day. That really underscores the perpetual interaction with the ice and the inherent dangers involved.
And one of the very first immersive experiences they had was this field gear shakedown and mock crevasse rescue. Actually inside a glacier. It sounds like being thrown in at the deep end.
Exactly. Before they could even begin their fossil hunt, they had to master these essential skills for living and working safely on the ice. And that includes confronting the very real threat of crevasses. These deep fissures in the ice can be hundreds of feet deep. And are often deceptively concealed by thin, fragile snow bridges. The author recounts the sobering story of a seasoned crevasse expert who tragically fell and died, highlighting just how treacherous these hidden dangers can be.
And the crevasse rescue training itself sounds both remarkably simple in its mechanics and absolutely terrifying in its potential consequences.
It is.
A system of ropes, knots, pulleys, and carabiners designed to haul someone out, but with absolutely zero margin for error.
That's the stark reality of it. The fundamental principles are straightforward, but the slightest mistake can have fatal consequences. And it underscores the absolute necessity for rigorous training and unwavering vigilance in this unforgiving environment.
Then we have Tim, the enthusiastic Australian member of the team, getting lowered into this crevasse. And his reaction is just pure, unadulterated awe. He describes this subterranean world bathed in blue light. These intricate illuminated ice crystals. These almost architectural formations, ice pillars, graceful folds sweeping eyes. It sounds like stepping into an entirely alien landscape.
It does. And Tim's description really allows you to visualize and almost feel that sensory experience of being encased in ice. So the way the dense ice filters out all wavelengths of light except blue creates that dominant ethereal hue. You've got these intricate crystalline structures sculpted by immense pressure and the slow passage of time. And this profound shift in the soundscape from the howling winds above to this hushed interior punctuated only by the sound of your own breathing and this subtle creaking of the ice like a frozen wind chime.
He even describes it as a sacred space, a blue chancel of an icy Gothic cathedral.
Wow.
Which is such a powerful and evocative image.
It is.
It truly conveys that sense of, profound isolation and the unique, almost otherworldly beauty that can be found deep within the ice itself.
And it also hints at the deeper stories that the ice holds within its structure. So as the author explains, glaciers act as natural archives, recording time through these annual layers of snow accumulation, gradual compaction, and eventual transformation into dense ice that traps tiny bubbles of ancient air. It's like a frozen geological record of the past.
And then there's this blue ice. This incredibly dense, ultra-compact ice from the deepest parts of the glacier that has this, stunning aquamarine appearance, but is notoriously treacherous because it's so incredibly slippery.
That's right. So blue ice forms far beneath the surface of the glacier and is forced upwards when that massive ice flow encounters an obstacle in the bedrock, causing the deeper layers to be exposed. And it's incredibly ancient, dating back millions of years in some cases. And while it poses a significant hazard for travel due to its lack of friction, the author beautifully describes this almost spiritual experience of drinking water melted from snow that fell when Neanderthals walked the earth.
It really underscores this constant intimate connection with ice in every facet of Antarctic life, right?
It does.
Camping on it,
Yeah.
melting it for drinking water,
Yeah.
using it as a transportation corridor.
Yeah.
And, of course, it has this profound influence on the weather.
Yes.
As evidenced by those fierce katabatic winds, these incredibly powerful blasts of cold air
Oh, yes.
that rush downhill
Yeah.
and can literally decimate field camps.
Those katabatic winds are a formidable force.
Yeah.
The dense, supercooled air accelerating as it flows downhill under the influence of gravity can generate wind speeds strong enough to send heavy equipment like snowmobiles airborne, as Forrest McCarthy vividly experienced. And beyond their destructive power, the wind acts as this persistent, invisible sculptor, shaping those stark, rocky landscapes and creating distinctive erosion patterns on exposed cliffs and boulders.
And then we encounter this paradox of the dry valleys.
Yes.
The surprisingly large areas of ice-free bedrock near McMurdo that are incredibly cold and stark, almost like a terrestrial analog for Mars.
Right.
It's baffling to think that you have glaciers clinging to the surrounding mountains and such frigid temperatures.
Right.
Yet the valleys themselves remain stubbornly ice-free.
It is a truly fascinating anomaly. The towering mountain ranges that encircle the dry valleys effectively block the flow of glacial ice from reaching them.
Right.
And those intense katabatic winds that we just discussed, they play a crucial role as well, scouring the valleys clean of any snow accumulation.
Oh.
So you end up with this cold desert oasis, a unique and surprisingly diverse ecosystem nestled within this vast ice-covered expanse of the Antarctic continent with these almost mythical names for the mountain ranges like Asgard and Olympus.
And even the seemingly uniform surface of the ice sheet is anything but, is it?
No, it isn't.
With these features called sastrugi.
Yeah.
These irregular wind-sculpted snow hummocks that can make polar travel so arduous, like trying to navigate a frozen ocean.
Yeah, it's like a frozen ocean of choppy waves.
Wow.
So the relentless blowing snow and the constant, albeit sometimes imperceptible movement of the ice creates this dynamic, ever-shifting surface, making overland travel challenging and demanding constant vigilance.
But it's this very challenging terrain that often leads to the most remarkable paleontological discoveries.
Yeah.
Right, with some of the most significant fossils found high on exposed mountaintops.
Exactly.
Imagine that literally ascending through millions of years of geological history, layer by layer of exposed rock, to finally uncover the fossilized bones and teeth of ancient sharks.
Right.
And armored fish, direct relatives of that Arctic fishapod on an Antarctic peak that was once part of a tropical river system.
It's amazing.
It truly underscores this fleeting nature of life and the necessity of adopting a much broader planetary scale perspective on environmental change.
It does. And these extreme polar landscapes offer this unparalleled window into Earth's long and dynamic history. And to gain an even deeper understanding of the intricate workings of this icy world, the author introduces us to this pioneering work of Eric Ricknott and the revolutionary impact of satellite imaging on the field of glaciology.
So Ricknott, with his background in mathematics and physics, recognized the immense potential of these early satellite missions like Landsat and this emerging field of remote sensing to fundamentally transform our understanding of these vast ice sheets.
Right.
It's almost ironic that when his supervisor initially suggested he focus his research on ice, Ricknott initially thought he was being given a less significant assignment.
Yeah, he thought he was being sidelined.
But it turned out to be this incredible gold mine of information.
It did.
Completely upending our previous conceptions about glaciers and their response to a changing climate.
Absolutely. So satellite technology provided scientists with this unprecedented ability to observe and precisely measure entire glaciers and ice sheets at once, effectively overcoming these immense logistical hurdles of conducting extensive field work in these remote and challenging environments.
Right.
And the development of sophisticated techniques like radar interferometry, which can measure minute changes in the Earth's surface with astonishing millimeter-level precision, provided an entirely new way to track the subtle yet significant movements of ice. Ricknott himself likened this technological leap to suddenly gaining a brand new pair of glasses.
And what those new glasses revealed was truly groundbreaking, wasn't it?
It
This
was.
discovery of these massive rivers of ice,
Yes.
several miles wide and hundreds of feet thick,
Yes.
flowing relentlessly from the deep interior of Antarctica
Yeah.
towards the coast
Yeah.
at surprisingly high speeds, in some cases over half a mile per year.
It was a complete paradigm shift in our understanding of ice sheet dynamics.
Yeah.
These satellite images revealed that the entire Antarctic ice sheet is in a state of constant motion, behaving like this enormous, albeit incredibly slow-moving conveyor belt. The implications are staggering.
Yeah.
The author points out that even a boulder located at the geographic South Pole
Right.
would eventually be carried to the ocean within a century
Wow.
by this relentless flow. And this movement is, of course, influenced by the underlying topography,
Right.
with ice flowing around, obstacles leading to the formation of those characteristic crevasses
Yeah.
and dramatic ice cliffs
Right.
at the coastline.
So this then raised a really critical question.
Yeah.
What are the primary factors that govern the speed of this glacial flow?
Right.
Its growth through snowfall.
Yeah.
And its loss through melting and iceberg calving.
Right.
The traditional view for a long time focused on this balance between snow accumulation inland
Yeah.
and ice loss at the edges,
Right.
with gravity simply pulling the ice downhill,
Right.
accelerating as the ice mass shrank and slowing down as it grew.
That's right. That was the prevailing conceptual model.
But the detailed data coming back from the satellites painted a significantly different picture.
It did.
Right? They revealed this rather surprising fact: only a relatively small fraction of Antarctic ice loss,
Yeah.
around 5%, is directly attributable to surface melting
Yeah.
caused by atmospheric warming.
So the real action, the most significant driver of ice loss, is actually happening at the interface, where these massive ice sheets meet the comparatively warmer waters of the surrounding ocean.
So this coastal boundary is where the most substantial ice loss is occurring.
Exactly.
And crucially, changes that happen at this coastline then propagate far inland,
Right.
influencing the stability and flow rates of the entire ice sheet.
Yes.
This makes the ocean interface the real business end of the Antarctic ice system.
It does.
And the GRACE missions,
Yeah.
the gravity recovery and climate experiments,
Yeah.
those ingenious pair of satellites nicknamed Tom and Jerry,
Right.
that meticulously measure tiny variations in Earth's gravitational field,
Yeah.
provided us with this ongoing weather report for the polar ice mass, allowing us to track these dramatic changes with unprecedented accuracy.
Exactly.
So it's the warmer ocean water that's primarily responsible for thinning and melting the edges of the glaciers,
Yeah.
not only eroding them from the sides and the front, but also melting them from below, creating this really concerning feedback loop
Yeah.
where the thinning ice flows faster towards the coast, exposing even more ice to the warm water.
Right.
The author's example of the Cadman Glacier losing a significant amount of height in just a single year
Yeah.
really underscores the speed and scale of this process.
It does indeed. And when you connect these relatively recent discoveries from satellite observations with those earlier historical observations made by mountaineers and explorers back in the 1800s, they're noticing that glacial valleys appeared much larger than the glaciers they currently contained, and they're finding those seemingly out-of-place erratic rocks scattered across the landscape. It all contributed to the eventual understanding of ice ages and the profound role of glaciers in shaping the Earth's surface.
Which completely reframes our understanding of the phrase glacial pace, doesn't it?
It does.
It's not this byword for extreme slowness.
Right.
Rigion's research and the satellite data clearly demonstrate that ice can move with astonishing speed, with significant and far-reaching consequences.
That's her.
Even some historical anecdotes of scientists finding their research huts slowly sliding downhill on glaciers and tracking stakes, moving surprisingly quickly, hinted at this faster pace.
Precisely. The common perception of glacial pace as being exceptionally slow is really a misnomer when you consider the actual dynamics of these massive ice systems.
Yeah.
And as the author emphasizes, these often rapid movements have profound implications for the natural world and our understanding of how it functions. And this deep dive has really only scratched the surface. Subsequent parts of the author's work delve into how this constantly moving ice shapes diverse habitats, acts as this remarkable archive preserving cosmic history, and ultimately has the potential to rapidly reshape our entire planet.
So as we bring this incredible deep dive into the world of Antarctic ice to a close, we've really seen just how unique and dynamic it truly is.
Yeah.
It's far more than just frozen water. It's this complex substance exhibiting solid, liquid, and plastic behaviors,
Right.
constantly in motion,
Yeah.
and intricately interacting with its surrounding environment.
It is.
We've explored that seemingly paradoxical ice is hot concept.
Right.
And its fundamental role in understanding glacial behavior.
Right.
And we've witnessed how this powerful combination of centuries of ground-based observations and cutting-edge satellite technology has revolutionized our comprehension of these colossal ice sheets.
Absolutely. And the extreme Antarctic environment, while seemingly remote and isolated, offers invaluable insights into the fundamental processes that govern our planet.
Right.
And even provides intriguing parallels for understanding other icy celestial bodies within our solar system, like Mars.
Which leads me to this final point for you to consider.
Okay.
Given this newly revealed, surprisingly rapid pace of glacial change, unveiled by, sophisticated satellite monitoring, this non-glacial glacial pace, how should our fundamental understanding of long-term geological processes be adjusted? What potentially unexpected and far-reaching consequences might arise from such dynamic and interconnected ice systems?
Yeah.
It's certainly a lot to think about as we continue to unravel